Hello, welcome back to Blender Sushi Live Noding. In this episode, we're gonna take a look at how we can kind of reverse engineer some kind of like motion. If we repetitively like doing a motion in certain way, I kind of wanna make a way so that we can reverse engineer what is that actually making that kind of motion. I'm not like a genius scientist or mathematicians or scientist or mechanical engineer, but I kind of curious how Disney actually does this in their research. I'm interested in this kind of motions. Maybe this motion is actually like a 3D, but in our case, I'll try to make it like a just 2D for now. I don't know how these things uh, actually works to create the motions, but maybe I can do a little bit of research for that after. So this is actually very interesting. All these gears being able to create this kind of like a simple motions that kind of looping. In the end, there are a lot of examples here in this video. You can watch it yourself. But something like this is really cool, like some kind of robotic or animatronic that's simply kind of doing the loop. So my thinking is that maybe if we are like kind of like doing something that's looping, basically whatever things that looping, we can turn it into some kind of procedural pattern that we can repeat over time. And obviously that's it's sometimes it's as easy as like just drawing the motions. Sometimes you want it to be more like some kind of functions. So let's just get started. So the idea is I want to be able to draw it first using grease pencil, draw the motions or capture the motions and turn the motions into some kind of functions that we can tweak and repeat. So this is a reverse engineer motion. It sounds very complicated, but I'm not like a genius, but I'll try to do that. So basically, let's say you ask someone to draw a motions that's kind of circular. We already know by heart that a circle you can simply make using a sine and cosine, right? But how do you get there if you want to reverse engineer it in Blender using Sverchok? So I'll try. So basically, I just draw like the motions multiple times. It's a hand drawn. Actually, I'm using mouse and it's not perfect, but it's making this kind of like a circle. So I'm going to go inside Sverchok, and I'm gonna use a grease pencil, and I'm gonna grab the grease pencil, get this guy, get the active frame, and we can see all these points corresponds to my mouse motions to generate the circle. All these points to generate the circle, and of course we get all these points and the edges. So we want to do like a quick observations of this this guy right here. So we want to use vector out. Grab all the points, separate the x and y, because with this circle and the 2D kind of motions, the z is always 0. Okay, so we know the z will be always 0, but the value of x and y over time, so time and value creates a motion, so over time the x and y value will change, and we can actually clearly see that if we're using the vector. Okay, this value, okay, for example, we have a time. We have the time that goes in the x directions, time, and the value is changing in the for this guy and this guy. So we need two, but we're gonna do it one by one. So the time, and we're gonna create some kind of range of value, maybe range float. This is probably like the time span. maybe 0 to 100, and step, we don't care. The count, how many samples. This is going to be the X. And we're going to preview it using viewer draw. That's our time span. And the value that's changing is from this circle is the X and the Y. So the X goes into the Y. Now we get something that looks like either sine or cosine. It doesn't matter actually, as long we can observe it. So we can shorten the time so we can see the graph. Increase the number of sampling. Okay, we can see, okay, until it stops. That's when the sampling's kind of finished. So we can see it's a sine and or a cosine, right? And the other guy, the same time goes in there, and the value that's changing is the Y, and we can observe it, and we get this. Let's give it a different value for a different color. I'm gonna use UV connection first of all and create the edges to generate the edges based on this guy. So we have this blue line, blue edges line, actually the red now, and let's do the other one. Give it a color. We can leave it blue. Actually, just get rid of the points, so we don't care about the points. Just see there's sine wave and then cosine kind of making like a slightly offset. It can be like a sine that's slightly offset, but it doesn't matter. But basically, the circle is generating this. So I'm gonna save this. The next thing I want to do, okay, we already kind of reverse engineer this circle, yeah. So the grease pencil, we can actually kind of edit the grease pencil and kind of move it slightly there, and then update it so you can see, okay, that's changing the sign in certain way. But let's make another example. I'm gonna save this real quick. So this is a circle. We already know it's a sine and cosine for value X and Y. Let's make some kind of like an infinity symbol. Okay, I'm gonna draw it 1 time, 2 time, 3, 4, 5, 6, 7 time, and it's, yeah, I think that should be enough. And now I'm gonna grab this grease pencil stroke and then update Sverchok, and we can see the data. So there is like, it's actually similar, like it's like a sine and cosine for the X and Y. I was actually pretty surprised with this result as well. And so based on this fact, we can really draw this kind of motion simply by using this sine and cosine functions. We just need to match it. This sine and cosine is actually kind of more almost like more stiff. So we know that a lot of math functions that already generate some kind of wave, you know, square or triangle. This one is almost triangle, but we're gonna use sine and cosine anyway. So let's keep things simple. Let's do one by one. Let's do this one first, the red color. We're gonna reverse engineer all this. So we already know this is the pattern we need to match. We're gonna quickly create it in Sverchok. So I'm gonna use a line to start with. And with this line, we're gonna quickly draw something. We're gonna preview it. Let's kind of increase it. So we have these points. We can always add the points later, but this line actually generates the value in X that's kind of growing, and the Y is always 0. But we're gonna change the Y. We're gonna modify the Y. So here we're gonna use vector out and vector in. Oops, sorry about that. So vector out, vector in. We actually don't need the edges for now, so vector in. So vector set it, we just get the points now. The y will we will modify it using the functions, math functions. The y is actually 0, right? It's not changing, so we're gonna use the x value and gonna modify it using sine or cosine. That's the familiar, the one that's the most the easiest actually. So now we have this sine functions going on this this guy right here. I can kind of change the number of vertices and then change the stepping, so we get a different sample. But we need to match this guy right here, this curve, kind of roughly. Let's use the math and use add. Add will offset the value for this these points for the function. So we kind of match it as close as possible. We're gonna use a multiplier here. Multipliers change the amplitude. So that's should be getting closer. And I'll offset it more. Gonna increase the sampling 250 and then reduce the stepping so we can see the points better. Let's offset it more, and then let's also kind of expand this thing, and let's see. Okay, that seems to be doing it. So offset, multiply, and this one's for some kind of amplitude. We can always offset it as well, but we don't need to do that. I think this is pretty good. So that's, we almost kind of matching the curve that we draw. Okay, we have one kind of a function ready for us. We're gonna hide it. So this is the red color one, the one at the top. We can hide it. Now let's draw the other one. We just simply can duplicate this guy and turn it on, and here we just dial this number and try to match it. We are using the same sine functions for this. We can use cosine, but I don't know if it doesn't matter for now. We just need to match the amplitude. So I think this is kind of good. I think that's about right. I don't know if it is changing over time as well. I think the accelerations currently with this kind of reverse engineering, we don't actually observe the accelerations or the motion speed slow down or things like that. Just matching the motions in space. Okay, seems like we matched both of them, and let's combine the two actually. How to combine this guy? Let me have a think. You just need to use another vector in, and really what you care is not the x, but the y, this value here. Combine the y and the x, and let's see what we get. There you go. So there you go. That's we kind of almost matched this motion graph. Maybe I did something wrong, or maybe we need to dial it until it's kind of perfectly matching the motion. Say like when the dots actually kind of matching, it's almost there. So obviously we need to be careful with the number here, but you sort of get the idea. At some point, the dots will kind of match and become like a single focus. Like this one is almost there. I think that's actually almost pretty close enough, and we just reverse engineer that motion we did there. Let me hide this now. Just look at the points. So now that we reverse engineer this as a functions, what we can do actually, how many sample we have? We have 362. We can actually increase this, like, let's make it like 500. It doesn't matter. It's gonna be like doing this for 500 frames, more or less. It's gonna do that, and we can use the points here, and just simply use list item and get this item, kind of like get the element of that points, and then now we can see that motions. This is the motion that I did using grease pencil at the beginning of this live noding. Okay, so if we use like a box, plug into this guy, we can see the box is gonna move in that kind of fashion. So I think as long the motion is like something that's looping and you just keep doing the same thing over and over, you know, like a dance or kind of like a kung fu kind of motions, you keep doing the same thing over and over again, you can study the motions, and then you can find the functions for it. That's kind of the thing that I think, how you can reverse engineer motions and reducing it into kind of like a XYZ. So you are kind of like simplifying it and find a mild function that can draw that. Maybe I'm oversimplifying a lot of things, but we can observe that data this way, I think. So yeah, there you go. That's how you can do some kind of reverse engineer emotions using Blender and Sverchok Add-On. Hopefully you find this one useful. It's a little bit complicated, but I don't know. I think this can be useful for you at some point. I don't know, even maybe for me. I really want to try. See, the next thing I need to figure out is that whatever motion we have, you know, like I don't know, maybe we can try one more motions, or maybe that's for the next time. But if we can figure out a function that does the motions, maybe we can also create like a gear kind of motions. I think I need some kind of engineers to help me to do that, but you can make like a toy that kind of doing repetitions like that. Yeah, so anyway, that's the whole live noding for today. Thanks again for tuning in. I'll see you in the next video. Thank you. Bye.